So I am coming back to this. So just a quick recap that whenever we are working on machine learning, the very first thing is defining the problem statement. Second is doing the data gathering. Third is data cleaning, or I would rather say data pre-processing. So cleaning is just a very small part of data pre-processing. We will talk about that. Then once we have clean data pre-processed, then we will do data splitting into two parts, the training data and the test data. Then we train the model, and after that we test the model with our test data, calculate the accuracy. And if the accuracy is accepted, we will deploy this model for the production for the end users, right? So that's how we will be doing this example today. So here, what data we have the insurance data, where a company has a problem statement that they want a machine learning model which can calculate the insurance premium for their customers based on certain features. So we have taken these 6 features here. We can have more features also as our need be. Okay. Now here we have age, gender, BMI, number of children's, smoker, a region in which that person lives, right? So this is the data set that we have. And as I was discussing earlier, this is our target and this is our input features, right? All this side. Now, what we have to do, we have the problem statement, we have the data. The third step is data pre-processing. In pre-processing, there are a lot of steps that we have to do. One of them is converting the categorical data into numerical data. So here you have gender as female and male. We need to convert it into 0 and 1. So let's say males can be 0 and females will be 1. Similarly, smokers are yes and no. We have to convert it into zeros and ones. We have regions. Now regions can be multiple regions, southwest, southeast, northwest. So you cannot convert it into 0, 1. Rather, it will be a 1, 2, 3, 4, like that. Okay. That's how we will be doing it. Okay. That is one thing in part of pre-processing. Second is in some places you can have missing data. Let's say the BMI was missing in this case, or the gender was missing in a particular case. So we have to look at whether we can generate the missing value, or if we cannot, should we remove that record completely, because that missing value can result in bad training. So either we can try to do missing value imputation. The term I am using here is we have to do data pre-processing. Okay. As part of that, one thing is the encoding. Okay, that is known as encoding. That is the keyword. Converting strings into numbers. That is known as encoding. Converting these into zeros and ones. That is encoding. The second is missing value treatment. Okay, missing value treatment, where one of the thing that we do is imputation. Imputation means replacing missing value with some proper value, maybe zeros, ones, or maybe some proper values, or remove the records, remove the records containing missing values. Okay, we can think about different things here. So these are some of the things which we will be doing today. Okay. So data pre-processing, encoding, missing value treatment, where either we impute the value by replacing missing value with some value, all those things. The other very important thing that we should do is data standardization. What is data standardization, or we can say data scaling rather? This is known as data scaling. Okay. What is data scaling? So consider this data that you have here. I have gender in the range of zeros, 1, 2, 3, like that, right? Your age can vary from, let's say, 10 to 100. BMI can also range in some 2 digits. So this data, it is good. But let's say now you also had salary as one of the feature here. And salary can be on the scale of thousands and lakhs, like 1,0,0,0,0,5 zeros. Then another person has 25,000. So what that means is the other columns are either unitary or on the scale of tens, but this data is on a very high scale. Now, if we train the model with salary column like this, it will overfit. It will create a bias on the model, and all the predictions will be highly dependent on the salary, because salary is having such a huge value. It will dominate the predictions. So what we need to do, we need to divide all the salary values by, let's say, 1 million or 1,000, so that salaries will be in the same scale as the other values. Okay, so scaling is a very important thing that you should understand. So what I'm trying to tell you is that just take an example that salaries are either like this. So that column we will be dividing by some, all the values of that column we will divide by, let's say, 10,000, so that the resulting values will come in the same scale as the other columns. And then we will use that transformed column for our prediction. We will remove the original salary column. Rather, we will use the derived column. So instead of the salary column, we will use the derived column, which is obtained by dividing every value by 10,000 or some other value. Because scale, all the columns should be on the similar scales. Otherwise, our model will be biased on that column. Okay. And why will that happen? See, go back to the mathematical equation. Y equals to m of x plus c, right? Now consider that now you have, instead of one, you have two features. So x1 and x2. So let's say x1 is age, and x2 is salary. Now, if my salary is on the scale of lakhs, if you put that value in this equation, and x1 is on the scale of only 10, the final output that you will get, it will always be dominated by this, right? Highly proportionate, y will be highly proportionate to x2, because it's a very big value in the mathematical equation. So we should not have that happen. So we need to scale this feature on the level of other features. Okay, so that is something very important we should take care of. This is all part of data pre-processing, and there are a lot of other things, but encoding, missing value treatment, and data scaling are some of the very standard things. Yeah.